Hello and welcome to Spy Math. This is Mr. Spy, and this will be the June 2018 Geometry Regents, questions 9 through 16. Let's begin. Question number 9. In the diagram below, segment AB is parallel to DFC, and segment EDA is parallel to segment CBG. Segment EFB and segment AG are drawn, which statement is always true. If we look at the diagram based on parallel lines, you have corresponding angles for parallel lines. The corresponding angles you have are angle EDF and EAB, and angle EFD and EBA. So if you look at the diagram, EDF goes to EAB, and EFD goes to EBA, forming two similar triangles. So we only know angles, so they cannot be congruent. That's the angle-angle triangle similarity theorem. Two pairs of angles formed by these two pairs of parallel lines. You actually don't need the other pair of parallel lines for this question. And the answer is choice 4, triangle DEF is similar to triangle AEB. So the small triangle above is similar to the small triangle, the whole triangle below. On to question 10. The base of a pyramid is rectangle with a width of 4.6 centimeters and a length of 9 centimeters. What's the height? The pyramid's volume is 82.8 cubic centimeters. Well, the formula for volume is 1/3 area of the base times the height. The area of the base is 4.6 times 9, which is 41.4 square centimeters. Substitute that in for capital B in the formula. 1/3 of 41.4 is 13.8 H. Cancel out the 13.8. 82.8 divided by 13.8 is exactly 6 centimeters. Choice 1 for the height. On to question number 11. In the diagram below, right triangle AED with segment BC parallel to DE. Indicate in the diagram with those tick marks right here. Statement's always true. Well, in this case, we're doing a part to whole ratio or a whole to part ratio because we're comparing two triangles with their parallel sides. So AB to AD is part to whole. BC to DE, those are just parallel sides. They go together, which is choice 2, because triangle ACB is similar to triangle AED, because they both share angle A, and they both have a pair of right angles, which is the angle-angle similarity theorem. Okay, so the answer is choice 2. If you want to look at the other choices, you see AC to BC, that's fine, but DE is not okay because we're starting with the parallel side again. If you look at choice 3, you get AC to CE, that's part to part. You can't do that when you're comparing the parallel sides. DE to BC, that's fine. DB is a part. You cannot use parts like the parts indicated in green when you're comparing parallel parts or sides. Question 12. What is the equation of the line that passes through point 6,8 and is perpendicular to the line whose y equals 3/2 x plus 5? So our original slope is 3 over 2. That means our perpendicular slope is -2 over 3, or -2/3. You look at your equations, choice 1 and 3 have the wrong slope, so you can cancel them out, leaving with choice 2 and 4. Substitute in the point 6,8, so you have y minus 8, plus -2 is x minus 6, and to remind you of what equation we're using, this is called the point slope form. Y minus y1 equals m times x minus x1. Wrote it twice, once here and once here. You substitute in points. Remember, the equation itself has negative signs. And that's very important, making a choice number 2. Question 13. The diagram below, parallelogram ABCD with diagonals AC and diagonals BD intersecting at E. Which additional information is sufficient to prove the parallelogram is also a rhombus? The thing special about a rhombus is the diagonals are perpendicular. So AC is perpendicular to BD, which is choice 4. Question 14. Directed line segment DE has endpoints point D at -4, -2, and point E at 1,8. Point F divides DE such that DF is in a ratio to FE of 2 to 3. What are the coordinates of F? Well, you find the x coordinate and y coordinate separately. So you set it up. Distance from D to E, 1 minus -4 is 5. And then you multiply by the ratio, which is 2 over the sum of the values, 2 over 2 plus 3, which is 2 fifths. 5 times 2 fifths is 2. Then you start from the beginning point, which is -4, add 2, and you get -2. Do the same thing for the y coordinate. 8 minus -2 is 10. 10 times the ratio of 2 fifths is 4. And then add that to the beginning value of -2 plus 4 equals 2. So the answer is choice 2. Separate the steps. Step 1, so you see them clearly. Step 2, and step 3. On to question 15. Triangle DAN is graphed on the set of axes below. The vertices of triangle DAN have the coordinates D at -6, -1, A at 6, 3, and N at -3, 10. What's the area of the triangle DAN? Well, in this case, since the triangle is not a right triangle and it's drawn at an angle, you have to find the area around the triangle by forming a rectangle and then subtracting out the 3 triangles labeled 1, 2, and 3 in Roman numerals. First, you find the area of the rectangle, which is a distance of 12 over here by 11. And you get 132. Let's undo the highlighting for a second and highlight back the area of the rectangle, so we're going to need that. Then you find the area of each rectangle separately. This one, triangle I labeled as triangle 1, is 12 by 4, which is 24, because half of 4 is 2. 2 times 12 is 24, because the area of a triangle is half the base times the height. We do the same thing for triangle number 2, where this length is 7, and this top length is 9. So 9 times 7 times a half is 31.5 units. And do the same thing for triangle number 3, which is 3 times 11, which is 33, times a half, which is 16.5. Unhighlight information. Now that we have the area of each of those 3 triangles, we find their sum. 24 plus 31.5 plus 16.5 is 72. Take that area from the total area of the rectangle is 132. Subtract out the sum of all 3 triangles is 72. And you're left with 60 square units, which is choice number 1. On to the final question for this video. Triangle ABC with vertices at A, 0, 0, B, 3, 5, and C, 0, 5, graphed on the set of axes shown below. Which figures form when triangle ABC is rotated continuously about segment BC? So we're rotating around this segment. You rotate around this segment, you're forming a cone with a radius of 5 and a diameter of 10. So you're forming a right triangle, so the original triangle was also right. Just mark with that right angle better. The original triangle was also right. Okay, the right triangle rotated forms a cone, which is choice number 2, which has a diameter of 10, a height of 3. Let's check the triangle has a height of 3. This distance right here is 3. This distance right here is 5, making it choice number 3. Thank you for watching. This is Mr. Spy, signing off.